So what if you were to build a programming language from the absolute ground up, with zero compromises, specifically for the world of Web 3.0? Well, that's exactly what we're looking at today, a strange, super opinionated, and honestly fascinating language called Merg-E.
Okay, so here's our game plan. First, we're going to nail down what Merg-E even is. Then, we'll dive into its pretty radical philosophy, see how it just completely flips the basics of programming on their head, unpack its wild take on parallelism, and finally, tie it all together to see why it was built this way for Web 3.0.
All right, first things first. We have to be super clear on this. Merg-E is not trying to be the next Python or JavaScript. Nope, it's got a very, very specific job to do.
Yeah, it's what's known as a domain-specific language, or a DSL. And what that really means is, it's not a Swiss Army knife. You're not going to build a website or a video game with it. Think of it more like a scalpel, right? A super precise tool made for one single complex operation. And that operation is Web 3.0.
And its laser focus is on the Inuendo Web 3.0 stack. Its whole reason for being is to write the brains for two things: Layer 2 nodes, the things that help blockchains actually scale, and for really high-performance bots running on that stack. It lives in this perfect little niche, right between the super complex crypto stuff at the bottom and the higher-level bot frameworks at the top.
Okay, so why is this language so weird? Well, it all comes down to its philosophy. It's built on these super strict, non-negotiable rules. And honestly, once you get these rules, all the strange stuff it does starts to make perfect sense.
It really boils down to these 5 core ideas. First, it's highly opinionated. It's my way or the highway. Second, safety is everything. Third, it's DAGs all the way down. A DAG, by the way, is just a way to structure data so it can't loop back on itself. Super important. Then you've got thin abstractions, which means it doesn't hide the messy details from you. And finally, it's obsessed, and I mean obsessed, with this idea called the principle of least authority.
So what does safety first actually look like? Well, think about this. In almost any language you use, if you want something to not change, you have to tell the computer, hey, this is a constant. Merg-E flips that completely on its head. Everything is constant by default. If you actually want a variable that can change, you have to go out of your way and explicitly label it as mutable. The safest way is the easiest way. It's brilliant.
And they take this idea so seriously. Get this, the language won't even compile your code if you don't indent it properly. No joke. It forces you to write clean, readable code because it believes that messy code, unclear code, well, that's just unsafe code waiting to cause a disaster.
All right, so that's the philosophy. But what's it actually like to sit down and write this stuff? Well, if you're coming from pretty much any mainstream language, Python, JavaScript, C++, you name it, prepare for a shock. This is where things get really, really weird, and that learning curve you hear about, yeah, it's more like a learning cliff.
Okay, first up, throw out your cheat sheet of keywords. If, for, class, while, all those words you had to memorize. Merg-E has just one reserved keyword: scope. That's it. Everything, and I mean everything, is built from that single concept.
So you need a list of things, or maybe a dictionary, or a custom data structure. In Merg-E, the answer is always the same. You get a DAG or you get a data frame. That is your entire toolkit. This is that DAGs all the way down idea made real, and it totally forces you to rethink how you even organize information in your program.
And this minimalist security-first mindset applies to how you structure your code too. Forget about object-oriented programming. There are no classes, no objects, none of it. Instead, you use these things called closures, which are just functions that can hold on to data. But here's the Merg-E twist. A function can't just grab any data it wants. You have to explicitly tell it, okay, you are allowed to see this variable and nothing else. That's the principle of least authority in action. Super strict.
Even something as basic as a loop gets a complete makeover. For loops don't exist. Gone. And yeah, you can type if and while, but they're not what you think. They're actually just a convenient illusion, some syntactic sugar hiding a much more fundamental concept called a structural iterator. This is a perfect example of what they mean by thin abstractions. The language gives you a little convenience, but it never hides the machinery underneath.
Okay, so all of these weird choices, the single keyword, only 2 data structures, no for loops, it's all been leading up to this. This is maybe Merg-E's killer feature. Its totally unique take on parallelism.
They call it zero-assumption parallelism. And here's how it works. As the programmer, you can give hints. You can say, hey, runtime, it would be awesome if you could run these things at the same time. And the runtime can literally look at your hint and go, nah, not right now. It has the final say, always. It decides what to do based on the system's current load and what it's capable of. You suggest, it decides.
So, why would you do that? Why give up that control? Well, here's the kicker. Because a single piece of Merg-E code is designed to run perfectly on 4 totally different backends, each with a completely different idea of what parallel even means.
So your one script has to work flawlessly, whether it's running on a basic single-threaded setup for testing, or on a powerful multi-core CPU for production bot, or even on an enhanced system that can throw work at a GPU. And get this, it could even run on the Beam, the legendary virtual machine that makes systems like Erlang so ridiculously reliable. So you write the code once, and it's portable and robust enough to thrive in any of those environments. That's the goal.
Okay, so now we can step back. After all that weirdness, the single keyword, the DAGs for everything, the, let's call it optional parallelism, it all finally clicks into place. Every single one of these strange decisions was made for a reason, and that reason is to solve a specific, painful problem in Web 3.0 development.
Think about it, that crazy obsession with the principle of least authority, absolutely essential when you're writing code for a decentralized system where you can't trust anyone. Forcing everything into a DAG? Well, blockchains and decentralized data are basically DAGs, so the language is speaking the native tongue of the problem. That zero-assumption parallelism, it's how you build rock-solid Layer 2 nodes that absolutely cannot fail, no matter what kind of machine they're running on. And those thin abstractions, they give you the fine-tuned control you need when every last drop of performance counts.
So what's the big picture here? Merg-E is a really bold experiment. It's making a bet that in the super high-stakes, security-critical world of Web 3.0, our general-purpose do-everything languages just aren't good enough. And that kind of leaves you wondering, right? Maybe the future of programming isn't about finding that one perfect language for everything, but about creating an entire toolbox of specialized razor-sharp instruments, each one perfect for its own specific task.